Imagine NASA pointing one of its most advanced telescopes toward a region of the universe that was supposed to be completely empty. Nothing. Not a star, not a galaxy, not even stray radiation. Just silence. Just darkness. But instead of the expected nothingness, the data that came back revealed something so strange, so impossible, that even NASA scientists didn't know how to categorize it. A massive cosmic void behaving in a way no void ever should. A region so cold, so energetic and mathematically inconsistent that NASA mentioned it once, quietly, almost cautiously, and then never explained it again. No follow-up press release, no detailed report, nothing. It was as if the discovery was too bizarre to touch publicly, but too significant to ignore. And this raises the question, what did NASA actually find inside a cosmic void that made even them go silent? Before we dive into the mystery, we need to understand what makes this so unsettling. Cosmic voids are enormous empty bubbles scattered throughout the universe, like holes in a cosmic web that stretches across billions of light years. They're normal, at least they're supposed to be. But this particular void wasn't normal at all. It was bigger, darker, colder, and far emptier than anything NASA or the European Space Agency had ever observed. It wasn't just an empty region. It behaved like something was draining energy from the universe itself. And when NASA's observations from WMAP and later the Planck satellite confirmed this anomaly again, the scientific world expected answers. But instead, NASA went quiet. The universe doesn't usually hide secrets this big, unless the secret is something we're not ready to understand. Today, we're going to explore what NASA found, why it shouldn't exist, and why the discovery was never explained again. When we look at the universe on the largest possible scale, it doesn't resemble a random scattering of stars. Instead, it looks like a gigantic cosmic web, long filaments of galaxies, clusters of dark matter, and swirling structures stretching for billions of light years. But between these bright, busy regions are enormous pockets of near emptiness known as cosmic voids. These voids are so vast that you could fit thousands of Milky Way-sized galaxies inside one, yet they contain almost nothing. No bright stars, no dense gas clouds, sometimes not even measurable dark matter. To cosmologists, voids are like laboratories where the normal rules of physics stretch to their limits. NASA studies these voids not because they expect to find something inside them, but because voids help reveal how the universe is expanding. By measuring how light bends, stretches, or fades when passing through a void, scientists can understand dark energy, the mysterious force pushing the universe apart. Normally, voids behave predictably. They're empty, cold, and quiet, but one particular void didn't match the pattern. It was too large, too cold, and too empty to fit into any cosmic model. And that abnormality is what triggered NASA's deeper investigation, and what eventually led to silence. Around the early 2000s, NASA's Wilkinson Microwave Anisotropy Probe, better known as WMAP, began mapping tiny temperature variations in the cosmic microwave background. Everything made sense until scientists noticed a strange temperature drop in one region, a massive, unusually cold patch nearly 1 billion light years across. At first, NASA thought it was an error, maybe a faulty sensor, a calibration glitch, or a visual artifact. But when the European Space Agency's Planck satellite later scanned the same area with even greater precision, it confirmed the anomaly. The cold spot was real. Its location aligned with a gigantic cosmic void called the Eridanus Supervoid, but the temperature drop didn't match what a void should produce. The cold region was too extreme, almost as if light passing through it was losing energy in a way physics couldn't explain. Galaxies around the void showed distortions that weren't predicted by any cosmological model. Something inside that void, something invisible, was interacting with the universe in a way we didn't understand. NASA acknowledged the anomaly in short technical notes, but no public explanation followed. The discovery was real, measurable, and utterly confusing. And it was only the beginning of the mystery. As more data came in between 2013 and 2018, the anomaly surrounding the Eridanus Supervoid continued to deepen. NASA detected unexpected energy patterns, almost like radiation was being siphoned away or absorbed by something undetectable. Photons from the cosmic microwave background appeared weaker when passing through the void, as if they were being stretched beyond normal limits. This effect didn't match any known property of space, matter, or dark energy. Something was interacting with light, but what? Several NASA teams compiled early interpretations, but none of them reached a solid conclusion. They found hints that the void might contain a hidden structure, something massive yet invisible, possibly clusters of dark matter, or something even stranger that our instruments couldn't detect. But after a few early mentions in academic reports, the topic quietly disappeared. NASA didn't revisit it in press briefings, didn't issue follow-up explanations, and didn't offer a theory to the public. The scientific world was left wondering if the data was too controversial, too uncertain, or simply too unsettling. The silence only amplified speculation. Did NASA detect something that challenges our understanding of the universe's structure, or did they find evidence of a phenomenon humanity isn't ready to explain? The mystery surrounding the void sparked theories ranging from scientific to mind-bending. One of the boldest is the multiverse collision theory. Some cosmologists believe the cold spot may be the bruise left over from when our universe collided with another in the early moments after the Big Bang. If true, it would be the first physical evidence that our universe is not alone. NASA avoids this explanation because it sits on the edge of speculation, but mathematically it fits some of the observed data. Another theory suggests the void is a dark matter desert, a place where dark matter, normally spread everywhere, nearly vanishes. That would rewrite cosmology because dark matter is critical to how galaxies form. Some physicists propose an even stranger idea, a cluster of primordial black holes hidden within the void. These ancient, tiny black holes wouldn't shine or emit radiation, but together they could drain energy from passing light. The final and most unsettling theory is that there's a flaw in our physics. Maybe gravity behaves differently on massive scales, or maybe the void is a sign of exotic dark energy structures we haven't discovered. Each theory is extraordinary, and none have been ruled out, and that's exactly why NASA stays cautious. When a discovery risks rewiring the foundations of physics, agencies move carefully. NASA's silence about the cosmic void might not be a cover-up, it might be scientific caution. Without clear conclusions, they avoid releasing theories that could mislead the public or ignite sensational claims. But some believe there's more to the silence. If the void really challenges current cosmological models, admitting that openly could shake public trust in science's understanding of the universe. Others think NASA may have found signals too weak or inconsistent to verify, and discussing them prematurely would create confusion. There's also the possibility that the anomaly hints at ideas that physicists don't want to discuss publicly, like universe collisions or exotic structures that could imply dimensions beyond our own. These concepts sit at the edges of accepted science, and institutions typically avoid them until evidence is undeniable. So the official response became no response. The void remains in NASA's data archives, unexplained. No retraction, no clarification, just a quiet acknowledgement that something unusual exists and that we don't yet understand it, and that silence leaves us with a haunting question. Did NASA step back because the discovery was too small, or because it was too big? The truth is, the universe still holds secrets so massive and so strange that even our most advanced technology can barely whisper their existence. The mysterious void in the Eridanus region, too large, too cold, too empty, remains one of those secrets. NASA measured it. NASA acknowledged it. But beyond those early observations, nothing more was ever publicly explained. No definitive theory, no confident conclusion. Just a quiet gap in our understanding. Like a blank page waiting to be filled by future science. And maybe that's the most unsettling part. Not that NASA found something unimaginable, but that the universe itself may be operating on rules we haven't even discovered yet. Maybe the void is a doorway into unknown physics. Maybe it's a leftover scar from the birth of the cosmos, or maybe it's something far stranger, something we can't yet name, because our scientific language hasn't evolved enough to describe it. What we do know is this: every strange anomaly, every unexplained signal, every cosmic mystery like this pushes humanity closer to the edge of discovery. And one day, perhaps soon, this silent void may reveal its truth. Until then, the biggest question remains: what exactly is hiding inside the emptiest place in the universe? And why did NASA stop talking about it?